Hello, everyone, and welcome back to our series on knowledge tracing. Today, we're exploring the next evolution of graph-based models, HGKT, JKT, SGKT, and DGMN. These models take the idea of a knowledge graph and make it dynamic, multi-layered, and capable of modeling forgetting and learning sessions. They represent a significant step forward from earlier graph models like GKT. Let's dive in. Here's our plan for today. We'll start with a simple analogy to understand the core idea of these new graph models. Then, we'll break down the key concepts like hierarchical graphs, session-based learning, and memory decay. We'll do a concrete calculation demo to see how information flows through these more complex graphs. A crucial part of this discussion will be comparing these new models to the earlier GKT. Finally, we'll explore how these powerful models can be integrated into your own research. To understand these new models, let's use an analogy. Older graph models like GKT are like a static 2D map. The roads are fixed, and the influence spreads in a simple, predictable way. The new generation of models is like a smart 3D navigation map. It has multiple floors representing different levels of knowledge, HGKT. It refreshes its view based on the current learning session, SGKT. It has a memory system that accounts for forgetting, DGMN, and it can see indirect connections, like how learning a foundational skill can affect a much more advanced one, JKT. This makes the model far more realistic and powerful. Let's break down the key concepts. The node state is the student's current mastery of a skill, like a health bar. The adjacency matrix defines how skills are connected. Think of it as a roadmap of knowledge. Message passing is how learning propagates through this network. Newer advanced models add powerful features. Hierarchical aggregation, HGKT, handles different difficulty levels of knowledge. Session graphs, SGKT, separate study sessions to avoid cross-contamination. Graph memory decay, DGMN, accurately models the human forgetting curve. And joint convolution, JKT, captures indirect skill relationships. Importantly, all these complex parameters are learned automatically from the data through backpropagation, making the model highly adaptive to different learning contexts. Let's walk through a concrete example. Xiaoming practices skill A and improves. The model then propagates this improvement to connected skills B and C. Next, it applies a forgetting factor to all skills, simulating the passage of 2 days. Finally, because the current learning session is focused on geometry, it gives skill C an extra boost. The final state reflects not just the direct practice and propagation, but also the effects of forgetting and the current learning context. This multifaceted update is what makes these new models so powerful. This is a crucial question. While GKT was a great first step, the new generation of models represents a major evolution. GKT used a static flat graph. The new models use dynamic, hierarchical, and session-based graphs that better reflect the evolving nature of learning. GKT only propagated information one step. The new models can capture multi-step, indirect relationships. GKT largely ignored forgetting. The new models have sophisticated, node-specific memory and decay mechanisms. Finally, GKT ignored the context of learning sessions, while SGKT explicitly models them. The result is a model that is far more realistic and capable. These new graph models are a perfect fit for your research. Their structure allows for a direct calculation of the distance to the optimal challenge zone. Session graphs can be aligned with different learning activities in your ebook data. Integrating your multimodal data is straightforward. You can use eye tracking features to initialize node states, adjust edge weights based on fatigue, or personalize the forgetting rate based on reading depth. Most importantly, these models are highly interpretable. You can literally see the path the model takes through the knowledge graph, providing actionable insights for teachers and students. Let's summarize. The new generation of graph models represents a major shift. They transform the knowledge graph from a static structure into a dynamic, multifaceted representation of a student's cognitive state. By incorporating hierarchy, sessions, and forgetting, they create a model that is far more realistic and powerful. These models are not only highly accurate, but also highly interpretable, making them an invaluable tool for both research and real-world educational applications. That's all for today's deep dive into the new generation of graph-based knowledge tracing models. We've covered their core ideas, calculations, and how they represent a significant advance over previous methods. Now, I'd be happy to answer any questions you might have. Thank you for your attention. Thank you for watching. If you found this video helpful, please like and subscribe for more content on educational data mining and knowledge tracing. See you next time.